Is it challenging for engineers to get the best components to maximize battery life and voltage regulation without taking up too much real estate on their boards or increasing the costs too much? I'm your host, Todd Baker, and in this episode of The Current, we'll be exploring the solutions to get the best power, the smallest components to fit your design needs. Hi, I'm Todd Baker, Corporate Vice President of Engineering at Future Electronics. One of the things that I think has probably been the priority of probably every embedded design since circuitry has been around has been maximizing battery life, maximizing the efficiency of voltage regulation in the circuits, and then also minimizing the amount of size required to get that high efficiency voltage regulation. And I think today in the applications that we're seeing come out more and more as I talk with design engineers out there, the need for that only becomes greater. Even though batteries have become better, even though technology has certainly improved, the actual power consumption of our processors and our microcontrollers and our radios are better. We still always want to maximize the battery life that we can get. I know, when I was doing a design some years ago for a tire pressure monitoring system for a large shipping company, and we had a very small sensor. It had to go inside of the wheel of a tire of an 18-wheeler, a tremendous amount of G-force in there, an absolute Faraday cage trying to get a 2.4 gigahertz it. And then on top of that, the customer's requirement for the design was that they have 5 years of battery life, because you certainly don't want to be able to have to change those sensors out on a regular basis. It was an enormous challenge, one, to get the voltage regulation to a point of high efficiency, and also keep it in a very small footprint so that my sensor didn't have to be too large. We see a lot of our suppliers coming out with designs that would have helped me a ton on that design, and I think can help a lot of engineers' designs today. And today I have the privilege to talk with onsemi, has a lot of great solutions in this area for voltage regulation with great efficiency in a very small size. So I'm talking with Bob Card, Advanced Solutions Group Marketing Manager of onsemi, and also Tim Kaske, Senior Director of Business Development of onsemi. So gentlemen, thank you so much for joining me today and sharing some of onsemi solutions. Could I really quickly ask you, Bob, to introduce yourself a little bit and tell me about your experience?
Sure. Thanks, Todd, for having me here. Yeah, I've been an engineer most of my life, so that I go back about, 8 or 12 years. I've been doing a lot of work with lithium-ion battery, optimized battery charging, kind of the wall-to-battery thing with smartphones. So I've got a lot of experience with USB chargers, lithium-ion, that whole thing. I can go back further, but that's relative to what we're going to be talking about today. That's a lot of my experience.
Excellent. And Tim?
Thanks, Todd. So Tim Kaske, I've been doing power management now for about 20 years, and it's ranged from DC to DC to high power DC to DC for Intel processors, point of load, and other applications, to AC to DC, so power supplies anywhere from a couple watts up to several kilowatts. And the last 4 years or so, really focused on portable power. So anything from IoT, industrial, and wireless type applications, but focused on linear solutions in the power management area.
Excellent. Well, again, thank you guys so much for joining me today and sharing some of your expertise. I really do appreciate it. So, what are you guys seeing today as you're talking with design engineers who are designing new embedded systems, need to maximize their power efficiency? Where's the market at? Where are the largest challenges for those design engineers, and how's onsemi working to help those engineers solve those problems?
Well, I can start. One of the things that I'm seeing is that there's a lack of understanding of how to calculate the battery life, how to really know how batteries work. I'm quite surprised when I talk to customers how few customers have actually cracked the data sheet of the battery they're using, or they have really any idea of how to use it. So that's one of the biggest challenges, is really understanding batteries and how to apply your load, your job, whatever it is you're trying to do with your thing, your IoT thing. Like for your case, for the tire pressure, you probably had, some sort of wireless device and a sensor.
Correct. Yep.
So you need to figure out how often you're going to be transmitting data, how much power the sensor uses, what's your advertising interval, what kind of topology what kind of technology you can use for transmitting. You can use BLE or something different. And you need a battery calculator for that.
Yeah. Yeah. Absolutely.
Yeah, I
Tim,
would
any
second.
thoughts?
Yeah, I would second that as well. I think it's people starting to think about the changes in technology that have happened with the different solutions from a power management perspective, and how that's changed over the 15 years since you maybe done that one as well. And in many ways, when people take a look at that battery, it's about how do you maximize the power that you have in it, and how are you using it. And on some of the devices that you have today, the speeds that they're operating in, if you have to transmit every 100 milliseconds, that's a long time in electronics today. And so there's different architectures now where you see you can turn off devices for longer periods of sleep time to maximize the power draw from the battery during that time, and then only turn on when you have to do that transmission.
Right.
And so when you're doing those sort of things, it changes the selections that you have from a power management solutions on what's important to you. So it's no longer about peak efficiency during that time. It's about how you're maximizing your efficiency during that off time, because in many of those applications, that's the majority of the time that you're sitting and doing pretty much nothing during that time.
Right. Yeah. How do you make sure that you got efficiency and in sleep mode, and
Right.
you got the lowest power sleep mode possible? Absolutely.
Right.
Yeah.
Right. So, for example, our Bluetooth device, the RSL10, if we put that in sleep mode, we have different sleep modes. We can wake up from being stimulated by a output, like one of our digital IOs gets pulled up or down, or we can wake ourselves up with a timer. And if we're woken up from the external world, our sleep power is 25 nanoamps when the coin cell. This would be using a coin cell is at 3 volts.
Right.
So we can really practically. I mean, it's hard to measure 25 nanoamps.
Yeah.
And then if we wake up with an internal timer where we've got part of our BLE stack is in memory, we can go as low as 160 nanoamps.
Yeah.
So that's Tim it's exactly right. It's really understanding your duty cycling between waking and sleeping. And to put things in perspective, the RSL10 can wake up and do a 3 advertisement non-connectable event in 7 milliseconds. So
Yeah.
at 100, so that's perfect. So if you're going at 100 millisecond interval, that's a 93% duty cycle of being asleep versus being
Right.
awake.
Absolutely, absolutely. And I think what we've really seen is that RSL10 Bluetooth radio from onsemi, really in a lot of ways, leading the industry and making an enormous splash in the industry, just as far as the amount of power consumption required for a Bluetooth design and how very low that it is. It's been very impressive. And while we're talking a lot about efficiency in a voltage regulation design, and that's certainly always critical, what about looking at things from the load standpoint? Are there any things that engineers and design engineers should be considering or maybe taking a look at differently when considering how to minimize the load on something like an RSL10 to ensure that the least amount of current possible is being required by their application circuitry?
Well, so the RSL10 was designed. We have a hearing aid group inside of On Semiconductor, and that really was the initial application. So from the grounds up, even in conception all the way through the final product, and when they taped out the design, it was all about running off a coin cell, or really a button cell.
Right.
So they dialed right in. So your typical coin cells, like a CR 2032, which is just kind of your typical coin cell, can be about the biggest capacity I've seen is right around 240 milliamp hours. So they dialed in the VCC. The RSL10 accepts a voltage from 1.1 volts up to 3.3 volts. And so a coin cell is typically 3 volts, and as it discharges down to about 1.8. So it's a really nice fit for a coin cell. Now, if you have an edge node, IoT thing that has actuation, you're never going to be able to pull that off with a coin cell. So you're going to have to go a lithium ion battery. So when you go into lithium-ion battery, which is a secondary cell, you can recharge it. Now your voltage ranges have changed. Now you're talking about a max voltage of 4.35, and when it's getting empty, roughly, give or take, 3.2, 3.4 volts. That's when you need an LDO to drop that voltage down to the
Right.
RSL10.
Right.
And that's
Right.
where Tim has one of the best LDOs I've seen on the market for that, which is the NCP 171, because it's fantastic because it can go, when its load drops down to in the order of a milliamp or two, which is exactly the scenario for deep sleep. Okay, exactly what Tim was talking about. You're
Right.
duty cycling things. You want to put things to sleep. If you have an LDO like the NCP 171, it draws, I think, 50 nanoamps of current to deliver that 1 milliamp of load, and that's phenomenal.
Right. Right.
Yeah, and I
Excellent.
think the conversations we've been having with customers around that is, many a times that an engineer is not familiar with the power management solutions that are out there. And so they think about, oh, I need the highest efficiency solution because this thing is battery powered. I need 10-year battery life. And they immediately think they need a switching regulator. And it's funny because I have a conversation with them and I say, okay, so what you need is a buck regulator. And they, yeah, buck regulator, switching regulator. And I'm like, no, they're not the same. A buck regulator is just one voltage to another voltage, and an LDO is a buck regulator, even though people don't think of them that way, right?
Right.
And
Right.
I feel like at times I'm really flipping some of these engineers on their head when I tell them that, hey, based upon your application usage, a linear regulator is actually more efficient for you versus a switching DC to DC. And they really got to be like, okay, show me up on this whiteboard what you're talking about, right? And then you really got to walk them through these numbers and you show them hey, you're only active during this period of time, and so your efficiency is this, but you have this really long sleep mode, and that's what's really drawing the energy out of your battery, and that's where you have to optimize efficiency. And that's where switching regulator is not as good in that period when it goes into this sleep mode versus a linear regulator and some of the methods that we can use within that device. And so that's why I think it's changing the way that people are seeing power solutions. And specifically, it's been a lot of this battery connected, wireless IoT, medical devices, things like that we're starting to see a trend where people are starting to see that, hey, there are other solutions out there for me.
Yeah. Yeah, and I think we've already hit on it quite a bit, guys. The whole Internet of Things, IoT, that's been a buzzword in the industry for at least the last 5 years. I think we've all been talking about it. I remember going back to 2015, 2014 when it was really starting to become one of those buzzwords, which I'm honestly not a huge fan of because I think it's a little bit too nebulous for me what exactly that means. But I think the promise of IoT, I don't feel like it's fully hit its stride. I think if we go back and look at 2015, we thought IoT in 2020 was going to be just, everything. Our toasters were going to be fully connected. Our refrigerators were going to be fully connected. And we're not there yet. Now, I still believe it's coming. I don't know about toasters and refrigerators. I'm sure there'll be some good applications for that. But I think it's continuing to expand. I still think it's a huge area for growth that everything in our lives is going to have some level of connectivity and is going to need to be transferring information and make that information accessible to users, to basically the designers of the products, and to other value added companies. So that's going to continue to expand. What are some of the things that onsemi is doing, specific as that continues to grow, as that continues to ramp? What are some of the things that onsemi is really doing to help design engineers maximize battery life in those locations where you may have a sensor node that's going to sit out in an agricultural field collecting, soil data for 10 years, and you don't want to have to touch that? Where's onsemi really doing a good job for those kinds of applications?
Well, I can.
Wait, Bob. Yeah, once you start on that, because I think it's really
sure.
around things
I just
like
had
the Go ahead, Bob.
Go ahead, Bob. Go ahead, Bob.
Oh, sorry. I just went through an experience with a customer who's in healthcare, and that customer is has a wristband. It's basically a BLE beacon, and there's a wristband that goes on patients, and there's that customer also makes asset tags that goes on equipment. They're little sticky asset tags, sort of like what Tile does. The idea is in every hospital room there'll be a gateway, a BLE gateway,
Yeah.
and so these beacons constantly transmit every couple seconds. They transmits where they are and what they're doing. And with that, I never really thought, but I started empathizing with the president of a hospital. So you got a hospital, you got like extremely well-paid assets, both animate and inanimate, some of the most expensive equipment in the world, and you have some of the most professionally trained people in the world. And the whole business and procedures and policies and processes are all based on chaos and emergencies. So it's hard I can't imagine keeping track of all the equipment, the people. Are you doing it right? Are you doing it wrong? How can you be more efficient? Well, if you put if you put beacons on people, I mean, it's kind of Orwellian, but you put asset tags on all the patients, all the nurses, doctors, janitors, everything. And with gateways in every room, you can really get a handle on what's going on. And you can make, when you start to think about buying equipment or appropriating equipment or, figuring out where you can, be more efficient, I can't imagine I'll be up all night. But with assets, with BLE beacons, which I think is a huge market. It's a huge market.
Yeah.
I'm seeing global market is going to go from like 1.3 billion to 31 billion from 2018 to 2026. That's a 30x increase in US dollars globally. And we're right, we're not too late, we're not too early. We're right at the right time. It's just, you're absolutely right. The IoT thing, I think it lagged a little bit, but I think it's going to explode. It's exploding right now.
Agreed.
So one thing I can help with that customer is the battery calculator. So I literally dialed into exactly what that customer wants to do for transmissions on his BLE beacon. And by the way, this is something I'm going to be, Todd, I'm going to be offering this service through Future in October 12th when we do our training, our virtual training. I'm going to be launching this program where I'm going to ask Future to reach out to customers that are in a similar situation that are using coin cells with a BLE beacon, hopefully ours, and I can calculate how long their battery's going to last.
Excellent. Yeah, and it's tools like that I think are absolutely critical. And I think the aspect that I think we've got to consider when it comes to any IoT is that people don't want these little bumps everywhere that are huge, bumps of circuitry that are maybe in a plastic housing or anything. Footprint of the overall design. It's got to start to seem, just built in, like you don't even know it's there. If people are seeing this kind of stuff, we don't want that. We don't want the eyesores of what IoT could be. So, the power efficiency, a big part of that design is not just the efficiency of taking the battery voltage, taking 3 volts and taking it down to 1.8 volts with the lowest quiescent current possible. It's also, how do I do that in a really small footprint? And so I think that's the other consideration that a lot of engineers have. Where's onsemi on that, and how do you guys help there?
I think I'll take that one. I think because I agree. I think a lot of that is customers are looking for final solutions. And one of the things that onsemi has is we have 14 different solution engineering centers across the world. And for a semiconductor company, none of those people work on semiconductor designs, the specific chips themselves. They're all focused on solutions, and they're focused on the block diagram. They're focused on how are our customers using it? And so that's where we see the demo boards and reference designs that we offer for sale through Future. We're trying to showcase them what is capable and what their end solution would look like, so that they don't have to go and innovate those things themselves. We can take that knowledge base that we have, and the power management is such a key piece of the total solution. How can you optimize that for size, for efficiency, utilizing some of the latest capacitors or inductors that we have in there to meet those size requirements, so that you can do those sort of things. Because you really got to show them what's possible, and then maybe they can envision how they can incorporate it into their end product. So that's really been a very key focus for us in helping the customers and I think is a leader in the market. When you say you're a leader in power management, leading means showing people how to do things. It isn't about just the product itself. It is that total solution that goes along with it. And so we feel like we're showing leadership in those areas to help drive those customers make better products for themselves.
Right. Yeah, and I think it is a crowded space that we're talking about, right? There's a lot of companies out there that do voltage regulation, and you're absolutely right. The days where when you're a design engineer and really the information you were looking for was somebody to bring in a catalog that had all the different parts.
Yep.
Now that's kind of been superseded. Then that got superseded by the web, so we could go get our data sheets and had all the information we needed there to get our design going a little bit faster. And I think it's evolved for design engineers even beyond that, exactly like you said. You've got the design engineer expects, hey, I don't want to figure out how your switching regulator works. I want you to show me how it works in my application. So because I got a deadline, I've got a boss that needs me to get this thing to market at a certain time, at a certain cost, with a certain functionality. And onsemi, I need you to help me with that. So is there anything you guys think you're doing in that way that you don't see other suppliers maybe doing as well? And then maybe you guys are really, kind of stepping out and making that easier on design engineers than anyone else is?
Yeah, I think there's two things. I think there's one is you're right. You got to drive performance in your products, and that's where I think we do have, as Bob mentioned earlier, some market leading solutions. And one of them we're really focused on is that low IQ. So the NCP 171 we talked about is 50 nanoamp, while still operating in a low power mode. And it's also built in that in many of these devices, it's about this transition from low power to high power. So it also has a very fast response time for any kind of event when you're going from 1 milliamp to 100 milliamps for some of these sort of events.
Right. So when you're going from sleep mode to fully awake, and I'm transmitting data.
Correct.
Yeah. Right.
So that's a key thing that you need to know on making that transition and doing it quickly, because they want to turn it on, do whatever they're going to have to do, and then turn it off again.
Yeah.
And so in that device itself, it's actually it looks like one device to the end customer, but in reality, the internal workings of it, it's actually two different power devices optimized for those two different modes of operation. And then we seamlessly transition between those two devices based upon the power load and others that's going on. So it's that sort of thing that we're seeing performance of it. Another area where we feel like we're really differentiating ourselves, we have a lot of patents on high PSRR performance. And so specifically when you're taking a look at wireless transmission, you're interested in the low frequency bands where you're actually transmitting data during that point. And so, 5-6 years ago, something at 80 dB of PSRR was seen as a very good performance. Well, now we're stretching 98 over 100 dB at very low frequencies. And so that's when you're transmitting any kind of information. You're not losing bits, you're not dropping bits, so you can do that transmission faster without any kind of disruption to it. So it's that sort of thing as well that's driving differentiation. That, I have customers in some applications where they say, oh, I'm using this device now and we're having all these errors, or we're seeing these disruptions that go into it. And then they drop our part in, because as you know, many of them are pin for pin compatible, right? So they drop our part in and they're like, oh my gosh, my application works now. And they look at the data sheet and they're like, I don't understand. What is the difference? Because if you just read the general first page of the data sheet, it looks like the same product. And I think that's where there's a lot of it. Well, yeah, but when you get into the details in the electrical characteristics table, which many engineers never get to that table, then you start seeing those differences. And that's where we're also trying to drive a little bit of truth in communication and tell them exactly what the part does in different areas. So in PSRR, many of our competitors, they only specify it at 10 kilohertz, and they'll specify some great number. But if you look at that spec at 100 kilohertz, it drops off maybe by half. So one of the things we're doing is we're specifying it at maybe 3 or 4 different variables, frequency ranges for PSRR. so the customer knows exactly what does the product do in their specific application that they're interested in. And so it's that sort of things. I think, you know, when you say leader, a leader also shows some of those things of transparency. And I get many of response from our customers where they talk about they really appreciate the detail that we put in our data sheets so that they can do their design on their own, right? So that they know they're pulling it down from the web. They don't have time to call an FAE, have them come into their office, they sit down in the lab. You need to make them self-sufficient. And so that's what we're trying to do now. And especially now when, you know, the FAE can't even come in and see him in the office.
Yeah. The meetings all look like this.
Yeah, exactly.
Yeah.
Well,
So go ahead, Bob.
yeah, a couple of things come to mind. One thing is, so if you're using lithium ion, we also have a fuel gauge that only burns the LC709204F. It only burns 2 microamps for active fuel gauging, which is like the nearest competitor that I could find is more like 60 or 70 microamps. So it's going to definitely make a battery application last longer. Another thing we're doing with our Type-C and USB is we've got state machine-based Type-C USB PD controllers and PD sources. So we've got the FUSB 3307. It's a full PD PPS programmable power supply PD 3.0 source, and it's all state machine-based. So you don't have to write any firmware. So it's much faster to market. And customers, so it's interesting how the world's changing. We used to have a much more narrow group of customers. Like each business unit inside of ON Semiconductor 10, 15, 20 years ago had maybe 5, 6, 7 major customers. Now something like USB, it's going everywhere. I mean, and a lot of these companies they don't want to deal with the firmware. The USB specifications, like the whole thing, there's 3 specs, and it's almost like 1,500 pages. No one's got time to go through all that and make sure they get it right. They could buy an ON Semiconductor controller, plop it into their application, and it works because it's all state machine based. And then we also have a new thing called Strata, which is very cool. So for those of you that are buying eval, you get eval boards from us and our competitors. You have to get the GUI, you download the GUI, and then you got to get something else, you download that, you get something else, you download that. What we have is a thing called Strata, which is a very beautiful thing. It's a platform. You load it into your computer, and if you get a Strata-enabled board from us, which most of our newer last year or so, if it has a Strata decal on it, you plug that board in, and Strata interrogates the board, figures out which one it is, downloads that GUI, puts it up, and then it adds the schematics, it adds the PCB layout, it adds the test results from testing that part, and also the user guide. So it saves you all those steps. Believe me, I know. I used to be someone that would, you go through 5 steps. You get the board, you download the GUI, you download the schematics, this does it all in one thing for you. So that's a big help too.
Yeah, no doubt. And to go back on what you were talking about as far as the USB powered device, I got to give a shameless plug for Future. We've got our Shaping the Future. We have an expert engineer, Paul Schmokel, who's actually teaching that product to customers individually. So if we've got any design engineers that are listening to this and would be interested to go into the details on some of that great USB PD product that onsemi has, Paul Schmokel's got that ready to go. And I'm telling you, he's going to bring you some insights on making that design happen a lot faster. So I think that's a very valuable thing and a great product portfolio. But it sounds like there's a ton of tools. We've already talked about different things different tools that onsemi is making available for design engineers. You alluded, Bob, to the battery calculator that you guys have and some other things. Are there any other tools that design engineers should take into account that onsemi makes available to them to make their design as easy as possible?
Tim, you want to take that?
No, I mean, I think the Strata boards are really the best things that we've seen coming in for them to start looking at how do I quickly and easily get up, and then the GUI allows them to adjust and change those pieces. Other than that, I think the other thing that I also get is Spice tools, right? So that's another one where everybody wants to create their own simulation and others. And I would say over the last 3-4 years, we put a lot of effort into online SPICE tools, having them download, be able to use those for those pieces. It seems to be more important for power management because they want to put it in and then have it interact with other things that are in their system that they're building, and simulate it before they go and make a commitment to, you know, a complete PCB design to figure out if it's really going to hit all the parameters that they want. So I think those are kind of the two key tools that I see engineers leveraging now to figure out they're in that design phase before they commit to it. And I think we're also seeing engineers are having more success on first pass of their PCB and others and getting that solution working for them versus having to go through multiple spins as they debug and figure out the hardware when it comes back.
Right, right.
And Tim mentioned we have an organization inside of ON that's called the SEC, or Solutions Engineering Center, and they're distributed all across their global organization. And they don't belong to any one business unit inside of ON. They're an offshoot of the sales organization, and they're a fantastic group of engineers. And what they do is they make these complicated reference designs. I'm working with one group, and we're going to make a smart speaker. We're in the process of building a smart speaker that's going to do, you know, Alexa, the voice recognition. It's going to have Class D auto amplifiers. It's going to have the microphones. It's going to have the LEDs and all the little pieces that, you know, the cap touch, all of those little pieces that need to work, that come together and work together. We provide the firmware, and that is a great jump start for customers. We do that for a lot of different products. And when you have I mean, it's one thing to do a reference design. It's another thing to do a system reference design. And typically, you know, traditionally in semiconductor companies, you've got these, you know, each business unit has their nose to the grindstone of what they make. And it's very difficult for them to just build a system. So we have this separate group that does a fantastic job of generating system reference designs.
Excellent, excellent. Well, Tim, Bob, I really appreciate the time, guys. I think this has been very insightful. There's no doubt there's some great, I think, developments and different methodologies that are making design a lot easier for engineers that are looking to maximize battery life in their systems. And I think we see that so often now with the expansion of the IoT. I think we're going to continue to see that with a lot of people tracking devices, battery operated devices that need to be on your person for personal health and public wellness, things along those lines. There should be some really exciting applications for engineers to be working on in the coming quarters, years, and decades. I think we'll see some exciting stuff. So really appreciate onsemi's insights on this and you guys' expertise. Thank you very much for taking the time to speak with me on it. If anyone watching has any interest in any of these topics, please feel free to email us at shapingthefuture, one word, at futureelectronics.com, shaping the future at futureelectronics.com. We'd love to bring our engineers in connection with your engineers and help you with the designs that you're working on. Again, Tim, Bob, thank you guys so much for the time. Have a wonderful day.
You too. Thank you, Todd.